All right, so we're going to be finding the smallest and largest values of our given function over the prescribed closed bounded interval. So to use the extreme value theorem to know that we have an absolute max and an absolute min, we need to make sure that our function is continuous on this interval. And it is. So we know that x plus 1 must be greater than 0 for our domain, and then the denominator says that x plus 1 cannot be 0. So if we take our logarithm, we say that x is greater than -1. Perfect. So that is within our bounded region. And x can't be -1. So again, within our bounded region. So now we just need to take the derivative to find our critical numbers, and our max will occur at the critical numbers or at our endpoints. So we're going to test all those points. So let's first find our derivative. And in order to do that, we must use quotient rule. So I'm separating our top and our bottom. So this would be 1 over x plus 1, and this would be just plain old 1. So let's move this guy over a little bit to give me some more room. So f prime of x is equal to, and we have to start with the first one, which is 1 over x plus 1 times x plus 1. So you can already see that that is just 1. And ln of x plus 1 times 1 is the next one. So it's this one. Sorry, let's do the little circle. This one times this one. That's 1. See, they just cancel. Minus this one times this one. So derivative of the first times the second, and then derivative of the second times the first. All right, and then all over x plus 1 squared. So we did our multiply, they cancel, and there we go. That is our derivative. So then we have to take that and set it equal to 0 and undefined. Well, the undefined is just going to be our domain issue. So we don't have to worry about it. I'm just rewriting it to make it look good, 0 and 0. And we don't have to worry about this one. This one is not an issue, so it's just the top. So 1 minus natural log of x plus 1 equals 0 is our equation. So if we rewrite it, and then we rewrite it, so this is a base e. So e to the 1 equals x plus 1. So x would equal e minus 1. So that is our critical number. So is it between 0 and 2? Yes. So this is 2.7. minus 1, so it's about 1.7 something, which is within our interval. So we're going to test those numbers. We're going to test 0, e minus 1, and 2 in a table with our function. So f of x, this is x, and then we will label them as a max or min, or neither. So we're going to plug 0 in, e to the 1 and 2. And so here's the nice thing with a graphing calculator. What we're going to do is plug that function into the calculator and then just graph it and take a look at it. So let's do that. So alpha y, there's our fraction. And then on the top, we're going to put natural log x plus 1. And then on the bottom, x plus 1. And then we're going to hit zoom 6, right? No, we're going to go to our window and we're going to put in our interval. So we only are looking at from 0 to 2. And then now we hit zoom fit, which is 0. And it'll graph just that region from 0 to 2, showing us what the max and what is the min. All right, so you can kind of see that's probably our e minus 1. So let's check it. Trace. And then we go second e to the 1 minus 1. We hit enter. And that's it right there. So 0.36, that's our first one. 0.3679. We'll do 4 decimal places. Now we're going to also plug in 0. So trace 0. That's our first one, and that was 0. So we already know what our min is. And then the other one. So if the 2 is higher than this, we know that's our max. But it looks like it comes back down. So let's hit trace 2. And it's 0.3662. 0.3662. So we know that this is our max because it's the biggest value. This is our min because it is the smallest value. And our function is continuous on the interval. So using the extreme value theorem, we know what our values are. So we have a minimum value of 0 at x equals 0. And we have a maximum value of 0.3679 at x equals e minus 1. Oops, a little bit off there. And that's it. So when they ask for extreme values over a prescribed bounded interval, all you have to do, closed of course, is make sure that it is continuous on that interval, and if it is, we must have a max and a min. You take the derivative, it tells you where the critical numbers are, and then you plug in the endpoints and that guy right there. That's our critical number, and whoever's the biggest is the max, whoever's the smallest is the min. There you have it.